Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. A compound has a plane of symmetry, is a mesocompound, when it contains stereocenters but an internal mirror plane makes it a chiral overall. For a molecule with two stereocenters bearing identical substituents, the mesoform has one R and one S configuration at the two centers, specifically the R-S or equivalently S-R diastereomer. Moving on to the next step. Define the groups. R group is equal to CH, Cl, CH3 and S group is equal to CH, Cl, Br. These two groups are different from each other. R has CH3, S has Br, so they are not identical substituents on the central carbon. Moving on to the next step. For a mesocompound to exist, the molecule must have at least two stereocenters with identical substituents so that an internal mirror plane can relate them. Mesocompounds arise when the same substituents appear in opposite configurations, cancelling chirality. And for the final step, all four positions are R-configured groups. This gives a molecule where all stereocenters are R. No internal mirror plane exists because all centers have the same configuration. This is a chiral molecule, or if identical groups, a specific enantiomer. No plane of symmetry. All four positions are S-configured groups. Similarly, all stereocenters are S, no internal mirror plane. This is the enantiomer of A. No plane of symmetry. The central carbon has R on top and bottom, S on left and right. However, since R group, CH, Cl, CH3 and S group, CH, Cl, Br are structurally different substituents, simply having opposite configurations at those positions does not automatically create a plane of symmetry. A plane of symmetry requires that the two halves of the molecule be mirror images. Because R group is not equal to S group, different substituents, no internal mirror plane exists. Since none of the structures in A, B or C poses a plane of symmetry A and B, because all centers have the same configuration, and C, because the two different types of substituents, R group with CH3 versus S group with Br, cannot be related by a mirror plane, the answer is D, none of these. Therefore, the correct answer is D. Therefore, the correct answer is option D.